The Avro Lancaster was a weapon of brutal industrial vengeance, but in 1940, it did not exist. There was only the desperate reality of a nation alone, besieged by air and sea. The British Expeditionary Force had been shattered in France. The Luftwaffe ruled the daylight skies. Britain's only means of striking back at the heart of the Reich was its Bomber Command, and Bomber Command was failing. Its fleet of twin-engine aircraft, the Wellingtons, the Whitleys, the Hampdens, were brave but inadequate. They were sent out in daylight, and they were slaughtered. They were sent out at night, and they were lost. In this new, total war, victory would not be decided by tactical brilliance alone, but by the relentless, crushing arithmetic of industrial production. Now let us return to the skies over a beleaguered Britain. The year 1940 had been a catastrophe. The fall of France was not just a military defeat, it was a strategic isolation. Great Britain stood entirely alone, a fortress island bracing against the expected tide of invasion. The Battle of Britain, fought in the skies above the southern counties, had secured the nation's survival, but it had not offered a path to victory. Prime Minister Winston Churchill knew that defense was not enough. To survive, Britain had to attack. With no foothold on the continent, the only weapon capable of reaching the German homeland was the long-range bomber. The Air Ministry had invested heavily in this concept, believing that a fleet of powerful bombers could cripple an enemy's economy and shatter its will to fight. This belief was now facing its first terrible test. The aircraft entrusted with this mission were products of a pre-war doctrine. The Vickers Wellington, the Handley Page Hampden, and the Armstrong Whitworth Whitley formed the backbone of the nascent Bomber Command. They were designed for an era of precision daylight bombing against specific military or industrial targets. The reality of that doctrine was suicide. When these crews, filled with a sense of duty, flew their machines over the occupied territories and into Germany, they were met by swarms of Messerschmitt Bf 109s and 110s. The bombers' defensive armament was meager, their airframes slow. Entire squadrons were eviscerated. The losses were not just tragic, they were mathematically unsustainable. The infamous Heligoland Bight raid in December 1939 had been the first warning. 22 Wellingtons were sent to attack German warships. 12 were shot down. The lesson was written in fire and aluminum. Unescorted daylight bombing was impossible. Reluctantly, Bomber Command was forced under the cover of darkness. This shift solved the fighter problem but created an entirely new one: navigation. In the 1940s, finding a specific factory or rail yard in a blacked-out European city after flying hundreds of miles by dead reckoning and celestial navigation was nearly impossible. Crews would fly for hours, cold and tense, peering into the blackness for a landmark that was not there. They were hunted by searchlights and ravaged by anti-aircraft flak. Often they returned having dropped their bombs on open fields, or worse, on the wrong towns. A shocking internal investigation, the Butt Report, would later confirm the grim truth. In 1941, it found that of all crews who claimed to have hit their target, only 1/3 had dropped their bombs within 5 miles of it. Against the heavily defended Ruhr Valley, the industrial heart of Germany, the figure fell to a mere 1/10. The strategy was broken. The aircraft were insufficient. Britain was spending immense resources and sacrificing its finest young men to achieve virtually nothing. The bombs themselves were small, often just 500-pounders. The aircraft could not carry enough of them to do meaningful damage even if they did find the target. A profound and terrible realization dawned within the Air Ministry. If Britain was to wage war by night, it could not aim for small, precise targets. It needed a new kind of weapon. It needed a bomber that could fly high, fly far, and carry a payload so vast that it could obliterate not just a single building, but an entire district. They needed a Sledgehammer. The existing fleet could not be adapted. The Wellingtons and Hampdens were already at the limit of their design. They were twin-engine aircraft, and the engines of the day, the Rolls-Royce Merlins and Bristol Hercules, were masterpieces, but they were not powerful enough individually to haul the loads required. The call went out for a new generation of heavy bombers. These would be four-engine giants, machines built on a scale previously unimagined. They were to be the physical manifestation of a new, more brutal doctrine: area bombardment. The short Sterling was the first to arrive, followed by the Handley-Page Halifax. They were steps in the right direction, but they were compromised. They had design flaws, limitations in their altitude, and difficult handling. They were not the war-winning weapon the nation craved. The pressure was immense. Every night the Luftwaffe's bombers were tearing the heart out of British cities: London, Coventry, Plymouth. The Blitz was a nightly reminder of Britain's vulnerability. The public demanded retribution. Churchill demanded action. The very survival of the nation depended on finding a way to prove to Germany, and just as importantly, to their American allies, that Britain was still in the fight. It was in this crucible of desperation, failed strategy, and industrial urgency that the seeds of a legend were sown. The solution would not come from a clean-sheet design, but from the ashes of a spectacular failure. The call for a new generation of heavy bombers had been issued by the Air Ministry in 1936 under specification P-1336. This document laid out an ambitious request: a medium bomber that could, paradoxically, carry an enormous payload, including the option of aerial torpedoes. It was a forward-thinking specification that anticipated the needs of a future conflict. Two companies, Handley-Page and Avro, known as Avro, submitted the winning designs. The Handley-Page design would eventually become the Halifax. The Avro design, designated the Type 679, was the Avro Manchester. The Manchester was, on paper, a revolution. It was large, sleek, and built around a deep, unobstructed bomb bay capable of carrying a staggering load. But the entire design was balanced on a single, critical assumption: to achieve the required power and lift without the drag of four engines, the specification had pushed designers toward two of the most powerful engines then in development. The engine Avro selected was the Rolls-Royce Vulture. The Vulture was an engine of immense ambition and equally immense complexity. It was not a new design from the ground up, but a composite. Rolls-Royce engineers had essentially taken two of their Peregrine V12 engines and bolted them together onto a single crankcase, one inverted beneath the other, to form an X-24-cylinder configuration. This X-24 marvel was designed to produce over 1,700 horsepower, a figure that promised to haul the Manchester into the sky with unprecedented speed and power. It was a technological gamble of the highest order, and it was a gamble that failed. The first production Manchesters were rushed to squadrons in late 1940. The crews who received them were initially proud. This was the machine meant to take the war back to Germany. But from the first day on the airfield, the Vulture engines were a source of profound dread. They were notoriously difficult to start. When they did run, they ran rough, vibrating with a deep, unsettling resonance. The real terror, however, began in the air. The Vulture's design was fundamentally flawed. The cooling systems were inadequate for the sheer heat generated by 24 cylinders packed so tightly together. The complex internal gearing that joined the two engine blocks was a weak point, prone to catastrophic failure. Pilots flying the Manchester quickly learned to watch their temperature gauges with more fear than they watched the skies for enemy fighters. Crews described flying the aircraft as a white-knuckle experience. The engines would overheat on the climb, forcing pilots to throttle back. In level flight, they were unreliable. Connecting rods would snap, shattering the engine block and spraying superheated oil and glycol across the wing. The most common and terrifying failure was fire. An engine would burst into flames without warning, giving the crew mere minutes, sometimes seconds, to bail out into the cold night air. The Manchester gained a grim reputation on the flight line. It was an aircraft more dangerous to its own crews than to the enemy. The operational record was abysmal. Squadron 207, the first to equip with the type, saw its serviceability rates plummet. For every aircraft that made it to the target, another would be forced to turn back, one engine feathered and the other running dangerously hot. Of the 209 Manchesters built, 78 were lost to non-combat causes, mostly engine failure. The aircraft was a strategic liability. It was consuming valuable resources, killing trained airmen, and failing to deliver the blows that Bomber Command so desperately needed. The crisis fell squarely on the shoulders of Avro and its chief designer, Roy Chadwick. Chadwick was a quiet, unassuming genius. He had designed the robust Avro Anson, and he knew the Manchester's airframe was sound. The fuselage, the deep bomb bay, the twin-tail assembly, these were solid, brilliant pieces of engineering. The aircraft's only flaw was its power source. The Vulture engine was a dead end. Rolls-Royce, struggling to perfect and mass-produce the smaller, infinitely more reliable Merlin engine for the Spitfires and Hurricanes, had no resources to spare fixing the complex Vulture. The program was effectively dead. Chadwick had seen this coming. He had watched the Vulture's problems with growing alarm. Long before the ministry was willing to admit the Manchester was a failure, he had been sketching an alternative. He believed in his airframe. He knew what it was capable of if it was just given reliable power. His solution was both radical and brilliantly simple. He proposed to scrap the two Vultures entirely. He would redesign the wing, extending it by 12 feet, and fit it not with 2 engines, but with 4. The engine he chose was the one that was already winning the war in the daylight, the Rolls-Royce Merlin. This was a massive gamble. It meant writing off the entire Manchester production line and admitting a costly mistake. But the alternative was to have no heavy bomber at all. In secret, Avro's engineers took a completed Manchester airframe from the production line. They worked with feverish intensity, modifying the wings, installing the new engine mounts, and fitting the 4 Merlin engines with their distinctive radiators. The new aircraft was initially designated the Manchester III. On January 9, 1941, Avro's chief test pilot, H.A. Sam Brown, climbed into the cockpit of this new hybrid. He ran the engines up. The smooth, familiar roar of 4 Merlins was a stark contrast to the Vulture's coughing thunder. He took off. The aircraft climbed with an eagerness the Manchester had never possessed. It was stable. It was powerful. It was, in his words, a delight to fly. When he landed, he knew. Avro knew. The Air Ministry soon knew. This was not a Manchester. This was something entirely new. The disaster of the Vulture had been the necessary crucible. From its ashes, the Avro Lancaster was born. The successful flight of the prototype, known then as BT-308, was more than just a successful test. It was a profound vindication for one man, Roy Chadwick. Chadwick was not a flamboyant showman. He was a quiet, meticulous engineer, a man who thought in terms of structural loads, stress tolerances, and production efficiency. His genius lay in his practicality. He did not chase theoretical performance at the cost of reliability. He designed aircraft that could be built, flown, and repaired by ordinary men under extraordinary pressure. He had believed in his Manchester airframe, and his 4-engine gamble had paid off, creating an aircraft with superb, viceless handling and a powerful, reliable climb. But the true genius of his design was not in the wings. It was in the fuselage. Chadwick's core concept, inherited from the Manchester, was built around a single revolutionary idea: the bomb bay. This was the feature that would set the Lancaster apart from every other bomber of its generation. Its 2 main competitors, the short Sterling and the handily Page Halifax, were also 4-engine heavy bombers, but they had been designed with a critical compromise. Their main wing spars, the massive internal beams that gave the wings their strength, ran directly through the middle of the fuselage. This meant their bomb bays were partitioned, divided into smaller compartments. They could carry a large quantity of bombs, but the size of those bombs was severely limited. Chadwick had found a different solution. He engineered the Lancaster as a mid-wing monoplane, but he routed the massive main wing spar above the bomb bay, passing through the upper fuselage. This was a more complex structural challenge, but it created an internal space that was revolutionary. The Lancaster's bomb bay was a single, cavernous, and completely unobstructed void, 33 feet long. It was a vast, empty tube, running almost the entire length of the aircraft beneath the pilot. At the time of its design, this seemed like an eccentric choice. The standard bomb load was made of 500-pound and 1,000-pound bombs. The divided bays of the Halifax and Sterling were perfectly adequate for carrying these. But Chadwick, and key figures within the Air Ministry, were thinking ahead. They were anticipating a new kind of war, one fought not with surgical strikes but with overwhelming concussion. Barnes Wallace, a brilliant Vickers designer, was already conceptualizing bombs of a scale previously unimaginable. The Air Ministry needed a weapon that could carry a single 4,000-pound cookie, a massive, thin-skinned cylinder packed with high explosives designed to flatten entire city blocks. The Sterling and Halifax could not fit it. The Lancaster could. It was this single design feature that made the Lancaster a true strategic weapon. It was not just a bomber, it was a heavy-lift transport for weapons of unimaginable destructive power. It was, in effect, the first blockbuster delivery system. This future-proof design meant that as the war progressed and the bombs grew larger, the Lancaster was the only aircraft that could adapt. The sheer lifting capacity was staggering. An early model Lancaster could haul a 14,000-pound bomb load to a target over 1,600 miles away. This was a load that no other bomber in the world could match. The American B-17 Flying Fortress, famous for its defensive firepower and high-altitude performance, was limited by its small bomb bay to a typical load of just 4,000 to 5,000 pounds on a similar range mission. The Lancaster could carry the payload of nearly 3 B-17s. This capability was not just a matter of numbers, it changed the very nature of the air war. The Air Ministry, led by the iron-willed Sir Charles Portal, now had a tool to execute the strategic shift they had been forced into. Precision daylight bombing was a failure. The new doctrine would be area bombardment, the systematic destruction of German industrial centers by night. To do this, they needed to overwhelm the defenses, level the factories, and shatter the morale of the workforce. They needed to drop a weight of explosives so immense that it could obel-type a city in a single raid. Roy Chadwick's design, with its massive open bay, was the only aircraft that could do it. The Air Ministry's reaction to the test flight was immediate and decisive. They canceled the remaining Manchester orders. The Vulture engine was officially abandoned. The entire industrial might of Avro and its shadow factories was to be turned over to one aircraft. The prototype was officially renamed the Lancaster MKI. The aircraft was not perfect. Its defensive armament was initially light, with 303 caliber machine guns that were outranged by the 20mm cannons of German night fighters. Its high-altitude performance, while good, could not lift it above the most intense flak. And it carried a dark secret. Its escape hatches were notoriously small and poorly placed, making it a death trap for a crew trying to bail out of a spinning, crippled aircraft. But these were problems to be addressed later. What mattered in the desperate winter of 1941 was that Britain finally had its Sledgehammer. Roy Chadwick's gamble had provided the weapon. Now the nation faced an even greater challenge, building it by the thousand. The Lancaster's successful test flight was a triumph of engineering. But a single prototype, however brilliant, was a curiosity. Bomber Command needed a fleet. The order that came from the Air Ministry was staggering, a demand that would have seemed impossible just months earlier. They did not want 100 Lancasters. They wanted thousands. This order was placed upon a nation already strained to its absolute limit, a nation whose factories were working day and night to build Spitfires, tanks, and ships, all while under the constant shadow of the Luftwaffe's bombers. Producing this new four-engine giant would require more than just a factory. It would require an industrial revolution. The architect of this revolution was the Shadow Factory scheme. Conceived before the war, this government plan enlisted non-aircraft companies, car makers, locomotive builders, heavy engineering firms to create a dispersed parallel manufacturing base hidden in plain sight. Avro's own facility at Chatterton near Manchester would serve as the parent, the central nervous system of a vast, new industrial body. But the muscle would come from everywhere. The first, most painful step was the conversion. The production lines at Avro and its partners, like Metropolitan Vickers in Trafford Park, were still tooled for the failed Manchester. These immense, complex jigs, massive steel frameworks that held the fuselage sections in perfect alignment, had to be ripped out. The blueprints were redrawn, the machine tools reset. This entire retooling process, a monumental engineering task in itself, was undertaken at frantic speed, often during the blackout, with the wail of air raid sirens providing a constant soundtrack of urgency. No single factory built a Lancaster. The aircraft was a mosaic, its pieces manufactured by a sprawling network of over 600 subcontractors. This dispersal was a key defensive strategy. If one factory was hit by a bomb, the entire program would not grind to a halt. One firm built wing sections. Another, miles away, specialized in engine nacelles. A furniture maker in High Wycombe turned its workshops over to producing the distinctive wooden tail planes of the de Havilland Mosquito, but also supplied components for the Lancaster. Miles of wiring harnesses were assembled by women in small workshops. Turrets came from one supplier, landing gear from another. This fragmented system demanded a new level of logistical control. Every component had to be built to an exacting standard, interchangeable with a part built 100 miles away. The finished pieces were then transported, on trucks, by rail, sometimes hauled through the streets, to the great assembly halls at Chatterton, Woodford, and Trafford Park. Here, the scale of the undertaking became visible. The Metropolitan Vickers plant was a prime example. Before the war, its workers built massive electrical generators and steam turbines. Now, they were aircraft engineers. They took to the task with a grim determination. Inside the vast, cathedral-like assembly hall, a production line over a third of a mile long was established. At one end, the first fuselage sections were laid down. At the other, a completed Lancaster, painted in the matte black of the night bomber, was wheeled out onto the airfield, its engines waiting for their first test run. This industrial miracle was performed by a new army. The experienced male workforce was gone, consumed by the armed forces. Their replacements were women. Tens of thousands of them, from every walk of life, stepped on to the factory floor. They were riveters, welders, electricians, and inspectors. They learned in days tasks that had once taken months to master. They worked grueling 12-hour shifts, their hands raw from handling cold aluminum, their ears filled with the deafening scream of pneumatic drills. They were the Rosies of Britain, and they built the Sledgehammer. At the heart of this entire system was the Rolls-Royce Merlin engine. Each Lancaster needed 4 of them. The demand was insatiable. The pressure on Rolls-Royce's main plant at Derby and its new shadow factory at Hillington in Glasgow was immense. The Merlin was a complex, hand-finished engine, a masterpiece of 27,000 individual parts. Its production had to be rationalized, streamlined, and accelerated without compromising its legendary reliability. A single failed engine on takeoff could doom an aircraft and its crew. The effort soon became an Allied one. To supplement the British production, a parallel line was established across the Atlantic at the Victory Aircraft Works in Malton, Ontario, Canada. These Canadian-built Lancasters, designated the Mark X, were identical, their parts interchangeable. They were flown across the perilous North Atlantic to join the swelling fleets of Bomber Command. By 1944, the system was a torrent. At its peak, the combined British and Canadian factories were completing more than 200 Lancasters per month. A machine of staggering complexity was rolling off the line at a rate of 1 every 4 hours. It was an achievement that defied the enemy's blockade and relentless bombing. This river of steel and aluminum flowing from hundreds of scattered workshops and powered by a civilian workforce was the unseen front line of the air war. The industrial might of a besieged nation had forged the weapon. Now it had to find the men to fly it. The stream of black-painted bombers rolling from the shadow factories was a testament to industrial resolve. But each Lancaster that left the assembly line was a dead, empty shell. It was a 30-ton machine of immense complexity, requiring a crew of 7 highly specialized men to bring it to life. The aircraft was a product of mass production. The crews would have to be forged in the same way. The demand for air crew was a voracious, unending maw. For every one of the 737-7 Lancasters built, Bomber Command needed a crew. And with the appalling loss rates that the coming offensive would bring, they would need replacements for those crews and replacements for the replacements. This required an industrial-scale training pipeline that spanned the globe. The call went out across the British Commonwealth. Young men volunteered in the tens of thousands. They came from the suburbs of London, the farms of Canada, the sheep stations of Australia, and the towns of New Zealand. Most were barely out of their teens, drawn by a mixture of patriotic duty, a thirst for adventure, and a desire to strike back. They were boys who would be forced to become veterans in a matter of months. Each man was a specialist, funneled into a distinct training path. The pilot, often the oldest at perhaps 21 or 22, carried the ultimate responsibility. He was the captain. He had to master the art of flying a machine heavier than a coastal freighter, hauling it into the sky with a full load of fuel and explosives, and holding it steady in a sky full of flak and fighters. Beside him sat the new, vital position created for these heavy bombers, the flight engineer. He was the aircraft's mechanic, its life support system. On his panel were the controls for all 4 Merlin engines, the fuel gauges for 6 separate tanks, the hydraulic systems, and the undercarriage. He managed the complex fuel transfers needed to keep the aircraft balanced on its long flight. He and the pilot formed a 2-man team just to fly the machine, a constant choreography of hands and eyes on levers and dials. Behind them, cloaked in a black curtain to preserve his night vision, sat the navigator. He was the intellectual heart of the mission. In his small, freezing compartment, he worked by the light of a single shaded lamp. With charts, dividers, a compass, and a radio direction finder, he had to plot a precise course over hundreds of miles of blacked-out enemy territory, contending with shifting winds and avoiding known flak zones. A 1-degree error in his calculation could send the aircraft miles off target. In the nose of the aircraft, the bomb aimer lay prone, his face pressed against the targeting panel. For hours, his job was to be a lookout, scanning the dark landscape. But for 3 minutes over the target, the entire mission rested on his shoulders. He guided the pilot on the final run-in, his voice calm in the pilot's ear. Left, left, steady, steady. Until he finally uttered the words, "Bombs gone." The wireless operator sat behind the navigator, his ears filled with the static and Morse code that was the crew's only link to their base. He tapped out reports, received vital weather updates, and, if the aircraft was hit, he was the one who sent the last desperate SOS. And then there were the gunners, the aircraft's defenders. The mid-upper gunner sat in a turret halfway down the fuselage, and the rear gunner, known as Tail End Charlie, occupied the loneliest position of all. He was in his own small, unheated metal and perspex cupola, isolated at the very end of the aircraft. He stared backwards into the blackness for hours, his hands on the grips of his 4 machine guns, knowing that the German night fighters almost always attacked from the rear and below. He was the crew's eyes, and their first line of defense. These 7 strangers were brought together at an operational training unit, or OTU. This was the critical moment of crewing up. Men from different trades and different countries thrown together in a hangar and told to sort themselves into teams. A pilot would look for a navigator he trusted. A gunner would size up a pilot he thought looked competent. In this haphazard, almost social ritual, a bond was formed that had to be stronger than family. These 7 men would live, eat, and fly together. Their lives would depend entirely on the skill of the other 6. Their training was brutal and intensely dangerous. They did not learn on shiny new Lancasters. They were given worn-out obsolete bombers, Wellingtons and Whitleys, aircraft that had been retired from the front line. Accidents were constant. Collisions, engine failures, and navigation errors claimed a horrifying toll. More men died in Bomber Command's training units than were killed in the entire Battle of Britain. It was a ruthless filter, designed to weed out the unlucky and the unskilled before they ever reached a squadron. Only after surviving the OTU did they finally move to a heavy conversion unit. Here, the crew met the Lancaster for the first time. The sheer size of it was a shock. Pilots who had trained on twin-engine aircraft now had to wrestle with the power of 4 Merlins. The noise, the vibration, the sheer weight. It was a quantum leap. They practiced takeoffs with full loads, flew high-altitude exercises breathing canned oxygen, and learned the emergency drills that might one day save their lives. They were a forged crew, a 7-part weapon, ready to be delivered to a squadron on the front line. There, they would be the new crew, the rookies, entering a battle of attrition where the odds of surviving a full 30-mission tour were, for a time, less than 1 in 4. The factories were producing the airframes, the training units were forging the crews. By the beginning of 1942, the stream of new Lancasters arriving at squadron airfields was growing from a trickle to a steady flow. This formidable new weapon, a sledgehammer of industrial production, was now in the hands of Bomber Command. But a weapon requires a will. It needs a doctrine and a commander with the iron resolve to execute it. On February 22, 1942, that commander arrived. His name was Air Marshal Arthur Harris. Harris was a man forged by the previous war. He had fought in the infantry on the African plains, then taken to the skies, and he had been horrified by the grinding, pointless slaughter of the trenches. He was gruff, obstinate, utterly single-minded, and possessed of a ferocious, impatient energy. He had little time for politicians, and even less for competing service branches like the Royal Navy, which he felt was trying to steal his aircraft for maritime patrols. His men called him Butcher, a grim nickname that reflected his apparent disregard for the staggering losses his crews would endure. To the press and to history, he would become known as Bomber Harris. He arrived at Bomber Command headquarters at High Wycombe with a singular, unshakable conviction. He believed that the war could be won by bombing and by bombing alone. He had read the Butt Report, the secret investigation that proved the utter failure of precision bombing. It confirmed what he already knew. Trying to hit a single factory at night was a fool's errand. He dismissed it as panacea bombing. Harris's doctrine was simple, and it was brutal. If you could not hit the factory, you would hit the city that contained it. You would destroy the workers' homes, the gas lines, the water mains, the electrical grid, and the transportation systems that fed the factory. You would, in his own stark phrasing, de-house the industrial workforce. It was a strategy of systematic destruction aimed at the enemy's morale, an attempt to make the continuation of the war so unbearable for the civilian population that the regime would collapse. This was the doctrine of area bombardment. The Lancaster was the perfect tool for this terrible new strategy. Its cavernous, unobstructed bomb bay was the key. Harris's predecessors had been forced to rely on small, 500-pound bombs, which made little impact on a stone-built city. Harris now had the 4,000-pound high-capacity bomb, the Cookie. This was a thin-skinned cylinder packed with explosive, designed not for penetration, but for pure blast. When it detonated at roof level, it sent out a titanic shockwave that blew indoors, shattered windows, and tore the roofs from entire streets of houses. It did not destroy the buildings, it opened them. This was the first part of a two-part attack. The true destructive agent was fire. Harris and his planners perfected the tactic of the bomber stream. The Lancasters, flying in a long, dense procession, would arrive over the target in waves. The first wave would drop the high-explosive cookies. Their job was to open the city, to expose the flammable interiors of the houses and apartment blocks. Close behind them, the next waves of Lancasters would unload their main payload, tens of thousands of 4-pound incendiary sticks. These small, magnesium-filled bombs rained down into the shattered structures, igniting the curtains, the furniture, and the wooden roof beams. This 1-2 punch was designed to create a firestorm, a phenomenon where thousands of individual fires merge into a single, monstrous inferno. The conflagration would become so vast that it would begin to suck in oxygen from the surrounding areas, creating superheated winds of over 100 miles per hour, capable of uprooting trees and pulling people into the flames. To deliver this payload, Harris's staff also refined the bomber stream as a defensive tactic. Instead of sending bombers in small, uncoordinated groups or on widely different routes, the entire raid, hundreds of aircraft, would fly the same path at the same altitude, timed to pass over the target in a highly compressed period. This dense stream would saturate the German defenses. The flak batteries and night fighter controllers on the ground could only concentrate on a few targets at a time. For the individual crew, it was a grim lottery. But for the command as a whole, it drastically reduced the loss rate per raid. Harris knew he had to prove his theory. The Admiralty was demanding his Lancasters for anti-submarine patrols. Churchill himself was skeptical. In May 1942, Harris conceived Operation Millennium, a single raid of 1,000 bombers. To achieve this number, he had to scrape the bottom of the barrel, pulling in crews from the training units, flying obsolete Wellingtons and Whitleys alongside his new Lancasters and Halifaxes. The target was Cologne. On the night of May 30th, the stream went out. The city's defenses were overwhelmed. In 90 minutes, Over 1,400 tons of bombs were dropped, two-thirds of which were incendiaries. The city burned. Over 600 acres of its medieval center were utterly destroyed. The raid was a tactical success and a massive propaganda victory. Harris had proven his point. The strategic air offensive, as he had envisioned it, was not only possible, it was now the central pillar of Britain's war effort. The Lancaster was its primary instrument. The industrial Sledgehammer had found the man who would swing it relentlessly for the next 3 years. While Arthur Harris perfected the firestorm, turning his bomber stream into a nightly bludgeon against the Reich's industrial cities, the Lancaster's unique design was capturing the attention of a very different kind of thinker. The aircraft's true genius was its adaptability. Its unobstructed 33-foot bomb bay was not just a container, it was a void of possibilities. For Harris, it was a way to carry an unparalleled quantity of incendiaries and 4,000-pound cookies. For an engineer named Barnes Wallis, it was the only platform in the world capable of carrying a single, revolutionary quality of weapon. Wallis, a brilliant and eccentric designer at Vickers, was obsessed with the physics of destruction. He was not interested in simply blowing up buildings. He wanted to shatter targets that were considered invulnerable, massive concrete dams, subterranean bunkers, and fortified U-boat pens. His first great challenge was the dams of the Ruhr Valley. The Möhne, Eder, and Sorpe dams were the heart of German industry. They provided the water and hydroelectric power for the entire Ruhr's steel and munitions production. If they could be breached, the resulting flood would paralyze the region. But they were impossible targets. The Möhne was over 100 feet thick at its base. A conventional bombing raid would only chip its surface. The Germans knew their value, and the dams were protected by heavy flak and, most critically, by heavy torpedo nets suspended in the water to stop any underwater attack. Wallis devised a solution that seemed to border on fantasy. He created a weapon codenamed Upkeep. It was not a bomb, but a 9,000-pound mine shaped like a massive oil drum. It was designed to be spun backwards at 500 revolutions per minute before being dropped. Wallis had calculated that if this spinning mine was dropped at an exact speed of 232 miles per hour, from an exact altitude of just 60 feet, it would not sink, but skip across the surface of the water like a bouncing stone. It would leap over the torpedo nets, strike the dam wall, and its remaining backspin would pull it down along the concrete face. A hydrostatic fuse would detonate it at a depth of 30 feet, where the water pressure would contain and focus the blast, acting as a massive hydraulic hammer against the weakened structure. The plan was audacious. It was also, from a practical standpoint, nearly impossible. The weapon was so large it could not be carried by any other bomber. To fit it into a Lancaster, the bomb bay doors had to be removed entirely, leaving the massive mine hanging partially exposed. The aircraft, a B-3 Special, also required a special hydraulic motor to spin the mine up to speed. This weapon demanded a new kind of crew. In March 1943, a special squadron, number 617, was formed. Its commander was Wing Commander Guy Gibson, a 24-year-old veteran of over 170 missions. His crews were hand-picked from the best of Bomber Command. They were given just 8 weeks to master the most difficult and dangerous flying of the war, sustained operational night flight at treetop level. To maintain the exact 60-foot altitude over water, The Lancasters were fitted with a simple, ingenious device. Two spotlights, one under the nose and one under the fuselage, angled so their beams would converge into a single perfect figure 8 on the water's surface when the aircraft was at the correct height. On the night of May 16, 1943, 19 Lancasters of 617 Squadron took off. They flew below radar, storming across the Dutch coast at hedge height, their navigators working frantically to find the pinprick targets in the dark. The losses were immediate, with aircraft torn apart by power lines and flak. When Gibson arrived at the Muna Dam, he found it heavily defended. He made his run first, his gunners firing, the flak tearing at his aircraft. He released his mine. It skipped perfectly. It detonated. A massive plume of water erupted. He then watched as one by one his crews flew their own runs into the inferno of tracers. One Lancaster was hit and exploded. Another was crippled. It took 5 mines, dropped with suicidal precision, before the dam finally gave way. A towering, 100-foot-high wall of water, a dark, gleaming mass, began to thunder into the valley below. Gibson then led the remaining aircraft to the Ader Dam, which also collapsed. Operation Chastise was a success, but at a terrible cost. 8 of the 19 aircraft were lost. 53 men were killed. But the dam busters had proven the Lancaster was more than a blunt instrument. It was a precision scalpel. Barnes-Wallis, however, was just beginning. His true goal was not water, but earth. He designed 2 new weapons, the 12,000-pound Tall Boy and later the 22,000-pound Grand Slam. These were not bombs in the conventional sense. They were hardened, aerodynamic, seismic weapons. Dropped from high altitude by modified Lancasters, they would break the sound barrier in their fall, striking the ground at over 750 miles per hour. They would penetrate deep into the earth, up to 100 feet in soft ground, before detonating. The explosion itself rarely destroyed the target. Instead, it created a massive underground cavity and a devastating earthquake, a camouflage, that would shake the foundations of any structure for hundreds of yards around, collapsing it from below. Again, only 617 Squadron and their specialized Lancasters could deliver these. The bomb bay doors were removed, the armor stripped, and the engines tuned for maximum power. With these weapons, they hunted the invulnerable targets. They collapsed the Saumur railway tunnel, isolating German panzer divisions before D-Day. They obliterated the fortress-like U-boat pens at Brest and Saint-Nazaire, their 20-foot-thick concrete roofs cracking like eggshells. Most famously, they were sent to destroy the German battleship Tirpitz, which lay hidden in a Norwegian fjord, safe from all other attack. After 2 operations, the Tirpitz was hit by several tall boys. It capsized and sank in minutes. The Lancaster, designed as a nighttime sledgehammer, had proven itself to be the most precise and devastating heavy bomber of the war. The Lancaster, whether wielded by the specialists of 617 Squadron or the massed ranks of the main force, had become the ultimate expression of industrial warfare. From 1943 onwards, the sledgehammer swung relentlessly. The great air battles of the Ruhr and the campaign against Berlin were not raids. They were sieges. Night after night, the bomber streams, now often 700 to 800 aircraft strong, poured over Germany. The Pathfinder force, flying high-speed Mosquitoes, marked the target with colored flares. Then, the Lancasters would arrive. A river of dark shapes in the night sky, unloading a destructive weight that dwarfed all previous conflicts. The apogee of this power was Operation Gomorrah, the series of raids on Hamburg in the summer of 1943. Here, all the elements of Harris's doctrine fused into a perfect, horrific storm. The dry, hot weather, the mix of high-explosive cookies and millions of incendiaries, and the saturation bombing all combined to create a firestorm of unprecedented scale. The city became a volcano. Temperatures reached 800 degrees Celsius. Asphalt on the streets melted and caught fire. The air itself was a superheated hurricane, pulling oxygen from miles around, suffocating those in their bomb shelters. The attack, repeated over several nights, virtually erased the city. Over 40,000 German civilians died, most of them in the firestorm. For the Lancaster crews flying 20,000 feet above, the sight was both terrifying and abstract. They flew into a sky lit by a man-made dawn. The glow from the burning city could be seen from over 100 miles away. They flew home with the acrid smell of the burning city sucked into their oxygen systems. A grim reminder of the destruction they had delivered. But this offensive was bought at a staggering price. The Germans were not passive victims. They adapted, creating the most sophisticated night air defense system the world had ever seen. The Kammhuber line was a web of radar stations, searchlight batteries, and flak zones, all centrally controlled. It was a deadly trap, and it was the hunter-killer groups of the Nachtjagd, the night fighter force, that served as its executioners. The German pilots in their Messerschmitt Bf-110s and Junkers Ju-88s, equipped with their own airborne radar, became aces in the dark. They stalked the bomber stream, looking for the telltale glow of a Lancaster's exhaust. A short, accurate burst from their 20mm cannons was often all it took. The most feared development was Schräge Musik, a system of upward-firing cannons. A German fighter could cruise unseen beneath a Lancaster, position itself in the bomber's blind spot, and fire a devastating burst directly into the aircraft's fuel-laden wings. For the Lancaster crew, there was no warning, just a sudden, catastrophic explosion. The rear gunner, Tail End Charlie, lived with this reality on every flight. He was the most vulnerable and often the first to die. The Lancaster, for all its virtues, was not a safe aircraft. It was a superb weapons platform, but its airframe was packed with fuel and bombs. Its escape hatches were notoriously small. When a Lancaster was hit and began its fatal spin, the centrifugal force often pinned the crew to their stations, making a bailout impossible. The statistics were brutal. Of the approximately 125,000 men who served in Bomber Command, 55,173 were killed. This was a loss rate of 44.4%. The chances of surviving a full tour of 30 operations were, for long stretches of the war, less than 1 in 5. This was a higher death rate than that suffered by infantry officers in the trenches of the First World War. As the war neared its end in early 1945, the bombing campaign reached its final, most controversial crescendo. The attack on the city of Dresden in February 1945, a city overflowing with refugees and of questionable military value, created another horrific firestorm. The attack, carried out largely by Lancasters and Halifaxes, has remained a dark stain on the Allies' conduct of the war. Harris, the unyielding commander, had his sledgehammer, and he swung it until the very end. When the guns finally fell silent, the Lancaster crews returned to a nation that was exhausted and impoverished. They did not receive the hero's welcome of their fighter pilot counterparts from the Battle of Britain. There was a quiet, national unease about what they had been asked to do. Harris himself was sidelined, and no specific campaign medal was struck for Bomber Command. The men who had fought this war of attrition, who had climbed into their freezing, vulnerable aircraft night after night, found their sacrifice shrouded in a complex moral ambiguity. They had been the instrument of a terrible, but perhaps necessary strategy to end a total war. The Lancaster itself, the industrial marvel that made it all possible, was quickly retired. Its day was done. But it left behind a dual legacy, that of a war-winning weapon that broke the back of German industry and that of a terrifying instrument of destruction. The Avro Lancaster was more than an aircraft. It was a symbol of a nation's desperate, total commitment to victory. It was a masterpiece of industrial design, born from failure and forged by a civilian army. It was flown by crews of extraordinary, almost unbelievable courage, who faced odds that were nearly suicidal. The Hellcat, by contrast, had been a weapon of tactical dominance. The Lancaster was a sledgehammer of strategic retribution. It proved that industrial might, when focused by an iron will, could bring an enemy to its knees. But it also proved that the price of such a victory is always, unfailingly, terrible. And that is why these tales must be told.